Thank you for your patience. So what I'm going to do is I'm going to share my screen, and I will go over a little bit about what is going on for today. And I'll talk a little bit about yesterday and answer any questions that people may have. All right, give me a second here. Let's go to, too many things. There's the Edulastic. There's my classroom. It was hiding. All right, so let's go to your class. And I just want to make sure, I mean, there's only 2 of you here, but there is student expectations that I put down. This came from the district. And so the student expectations kind of list some of the things that sort of concerned me with why I went through the trouble of making this a little bit more secure connection. Creating a space, break up the day, engaging with the classroom, follow the code of conduct, demonstrate online learning etiquette, which is what I think we saw a lack of yesterday. So I just wanted to make you aware that that was there. As far as classwork, so let's kind of go through where we are. All right, so kind of give you the rundown of the last 4 days so you sort of know where we're going. On day 1, I had you look at atoms and subatomic particles, get a feel for where they are and kind of how to count them. And then I had you look at chemical bonding in day 2. And the idea was for students to get the idea that atoms combine by the way they share or exchange electrons. And atoms like to have, well, they like to follow a rule. It's called the octet rule. And they seem very happy when they have their outermost energy level either completely full or they have a total of 8 electrons in the outermost energy level. So when atoms either share electrons or gain or lose electrons, they're doing so in a way that allows each of them, however many there are, however many elements there are, to feel like they have a full outermost energy level or have a total of 8. So if you look at something like, say, salt, so what we'll do is we'll look at just briefly the notes from yesterday. They were in a PDF, and without the PDF, you don't get the animation piece. So there happens to be this particular slide. This slide, if I had given you the actual PowerPoint, and I can do that if that's something you want, just reach out to me and I'll give you the actual PowerPoint as opposed to a PDF of it. But in this particular slide, this electron right here actually first starts on the sodium. And what they're showing is that that electron jumped from one to the other. And what I can do is pull up that slide. How am I going to do this? Give me a second to put my thumb drive in, and I'll show you that animated. Take me 2 seconds here. Course files. Let's make sure where it is. That is correct, and that was 2.1. And I think these are the notes. Yeah, so let's go here. All right. Oops, let's go through. Those are isotopes. All right, so here's that same slide. So what you're looking at is sodium. So these are ionic bonds. These are atoms that would exchange electrons. You can either share electrons or exchange electrons. In sodium and chlorine, they literally give up electrons and one takes an electron. So when we look at this, if you look at the sodium atom, you'll notice that sodium has 3 energy levels. It's kind of hard to see, and the mouse sort of disappears here, but it's this energy level is 1. And if you remember, there's 2 electrons that can fit in the first energy level. And then this is the second energy level, which is 8. 8 electrons can fit in the second energy level. And then there's 18 that can actually fit in the third energy level. This particular atom has one electron in its outermost energy level. So if you remember what I said, atoms like to have either 8 electrons in their outermost energy level or have that energy level full. It'd have to have 18 electrons. That's pretty hard to do. But it's really easy to lose this electron. And if it did that, then it would only have 2 energy levels, and the outermost energy level would have 2 things. 1, it would be full, and 2, it would have 8. So it actually satisfies both rules of the octet rule. The chlorine atom, on the other hand, has a 3rd energy level, and it has 1, 2, 3, 4, 5, 6, 7 electrons in its outermost energy level. Now, it'll never be full. Well, it could be full, but in order to be full, it would have to gain 11 more electrons. But it could get 8 electrons in its outermost energy if it gained 1. So, yeah, go ahead.
There are people in our class who are trying to join, but it says that it's locked.
It is, yeah. And the reason I had to lock it was because I had too many inappropriate behaviors that happened yesterday. So I've chosen to lock it, but let them know that it is being recorded. So they can't, I'll post it and they'll be able to watch it at a later date. I'm only giving them a 5-hour window to join.
Okay.
All righty, sorry. So anyways, what's going to happen here is because there is 7 electrons in this outermost energy level, and it needs either 8 or full, it's easy to gain 1 electron. So what'll happen is the electron that's in the sodium will actually go over to the chlorine. And that's what we call an ionic bond. And what's happened is that 3rd energy level has now disappeared in the sodium, and the electron has moved over to the chlorine. So in the PDF version, that's what you see. You don't see the animation piece. Again, first time go around, first week, I will post the PowerPoint version as well. And if you have a PC at home, you'll be able to play that. And so now if I go back to the previous slide, you'll see that there are 11 protons and 11 electrons in this scenario. And there are 17 protons and 17 electrons in the chlorine before any of the electrons are exchanged. Once they exchange, now the sodium has lost an electron, so now its overall charge is +1. If I give up 1 electron, I still have the same number of protons, but I gave up an electron, so now the atom is overall positively charged. The chlorine, which had 17 protons and 17 electrons, just gained an electron, so now it has an overall negative charge. So this is a classic case of ionic compound where you have the substance salt, and it's written Na plus Cl minus. Na plus because I've lost my electron, and Cl minus because I've gained an electron. And that's really important because having that positive and negative charge allows substances like that to dissolve in other substances that are also charged. That's where water comes in. So enough of ionic bonds. Then you get to covalent bond. And so a covalent bond is when atoms are sharing electrons. And water is a perfect example. And that's the one we're going to go with because that's what really the rest of the unit is based on. And so water, without going into too much detail, oxygen in water has 8 protons, which means it has 8 electrons, which means it has 2 electrons in its first energy level, and then it would have 6 electrons, get my mouse to come back here, 6 electrons in its outermost energy level. So here's the first energy level, and there's our 2 electrons, 1, 2. And then our second energy level actually has 1, 2, 3, 4, 5, 6. Now I'm not counting these 2 because those are actually the electrons that are in the hydrogen. So hydrogen has 1 electron in its energy level because it has 1 proton. So 1 proton means it also has 1 electron. But it doesn't give up its electron. What it does is it shares its electron. Because remember, atoms like to have either their outermost energy level full or 8 electrons in their outermost energy level. Now, hydrogen only has 1 energy level. It can't have 8 because its 1 energy level can only hold 2. So in this case, for hydrogen to satisfy the octet rule, it would have to have its outermost energy level full, which means it would have to have 2 electrons. The same with the other hydrogen. So what the hydrogens do is they share their electron with the oxygen. So they're kind of giving, I don't want to say giving, they're sharing their electron with the oxygen. Each of them are sharing one. So now it's like the oxygen's happy, right? Because it's sharing one electron from one atom. So it went from 6 to 7, and it shares another electron with another hydrogen atom. So now it just went from 7 to 8. So it's now satisfied the octet rule. And each hydrogen is sharing one of the electrons from the oxygen. So now it thinks it has 2. That's what a covalent bond is. Generally in a covalent bond, there's no difference in charges. But here's the caveat, and that's why we're teaching you this, is that in water in particular, because oxygen has more protons, the electrons are really hovering around this whole thing. That's really what they're doing. They're flying around the whole thing. But because oxygen has 8 protons, they tend to hang out in the oxygen end of the molecule. So if you were to draw this molecule and you were to somehow put a positive and negative charge, the molecule itself would have a slightly negative charge near the oxygen side of the water and a slightly positive charge on the hydrogen end of the water. So it's not an ionic compound, it's a covalent compound, but because oxygen is so much bigger than the hydrogens, it's drawing the electrons towards that end of the molecule. And so water ends up having this slightly positive negative charge. Well, that's a huge advantage. So that's what gets us to where you are today. So what I'm going to do is I'm just going to open up the notes from today. Let me go back. Let's do, all right. Give me just 1 second and I'll open up the notes. These are right in the Google Slides, but I'm just going to open up the actual PowerPoint since I have it open. And I believe we're section 2. And I think that's the one I want. Okay, so now you get to today's activity, and you're going to be looking specifically at the water molecule. So when you do the activity today, there's something called a POGIL. That POGIL will have this image in it a number of times. And the gray shading area is showing you electron density. So what this image is showing you is that the oxygens tend to hang out on the oxygen side of the molecule, less so than they are on this side. That's why it's shaded in a little bit darker here and a lot lighter here. And the idea here is for you to get to understand how water then dissolves substances like salt. So, I don't want to confuse you. So, okay, let's just take water, for example, by itself. So if you just looked at water molecules and you imagined a glass of water, because water has this positive and negative end, when water molecules are adjacent to one another, and adjacent means next to one another, when they're next to one another, they orient themselves so that the positive end of one water molecule is attracted to the negative end of another water molecule. And so if you were to draw 100 of these things on a piece of paper, that's how you would orient them. The negatives and the positives would all be connected, making a lattice work of what would be water. If anybody has a question, pipe in. Just, I mean, you can chat it or let me know. At least there's a chat. There's also a raise hand feature too that I think I can see just in case, because I want to make sure I don't want to lose anybody.
I have
So,
a quick question.
Go ahead.
It's not about the actual notes or anything, but for the assignment today, it says like we have to complete the property of water's activity, and
Yep.
it's just a PDF. So do we do it on like a separate Google Doc?
Yeah. So what I would recommend that you do is to just, you can do it on a Google Doc if you want. You could do it on a piece of paper. So what you do is fill that activity out, put it on a piece of paper, and then when you go to the Edulastic, it's that activity, and it just asks you to put in your answers to not every single one. It asks you to put in your answers to like 10 of them. But make sure that before you do the Edulastic, that you write your answers out, because to try to keep it so that there's some academic honesty and we're discouraging academic dishonesty is that I put a little time limit on it of 30 minutes. It's way more time than you need to fill it out, but it would be hard to do it in 30 minutes if you like opened it up and started, like, in other words, if you went to the Edulastic and just started answering the questions, it would be hard to do it in 30 minutes. So I thought, how about have the kid look at it on the PDF, write the answers on a piece of paper, and when they go to the Edulastic, just read your answers off the piece of paper and type them in. It'd take you no more than 15 minutes.
Okay, thank you.
Sure. And again, just give, provide me feedback if this is too much work, too little work. Well, I know you're not going to tell me if it's too little, but I have a 15-year-old daughter myself, so I know how much work she's doing and how much time she has available in a day. But if you feel like this is becoming overwhelming, if you just let me know, that would be fantastic. All right, I appreciate it.
Okay.
So what's going to happen is water molecules basically combine with the positives and the negatives. This is what gives you like surface tension. So if you imagine water and the top of, like, for example, in this image, the water spider is literally sitting on the water, and the surface tension is that positive negative attraction that's between the molecules of water that's keeping that there. It's also what gives water its ability to climb stuff. And I'm kind of moving ahead here, but if you remember in science class, there's something called the meniscus, which is when you're looking at a graduated cylinder, the water tends to kind of curve up the inside of the glass. And that's because the glass is charged and the water molecules are charged. Remember, they're slightly charged, and they use those charges to kind of climb up the glass. This is a good kind of like visual where, remember what I said, the oxygen has a slightly negative charge and the hydrogen side of water is slightly positive. So when I look at this image, I can tell that this, let's assume this is glass inside a graduated cylinder. The glass, I'm going to assume, is positively charged because all of the negative ends of the water molecule are sticking to it. And they're also pulling on the adjacent water molecules with it. So water climbs the glass, and at the same time, it's pulling on the other water molecules using those charges. That's essentially what you're learning today in the POGIL, is kind of getting your head wrapped around this idea that even though water is sharing electrons, the electrons are hanging out on the oxygen end of the water molecule, giving water a slightly polar charge, meaning more negative on the oxygen side and more positive on the hydrogen side. That's all of today. Tomorrow, you'll actually either cut out these little things and arrange them on a piece of paper, or you can draw them to kind of draw an illustration very similar to what you see right here in front of us. And then you would take a snapshot of that, either with your phone. So tomorrow would be the first time you would upload something in Google Doc as a piece of evidence. And then there are 4 questions to answer. You don't have to cut them out. These are the cutouts here. I'm going to go ahead and I'm going to make I already made a video, but I'm going to make another instructional video to show how kids could cut them out if they want, but not everybody's going to have access to a printer, or you can just draw them out. And so just foreshadowing for tomorrow, it's going to be a 2-part activity. And Friday is basically the second part of tomorrow's activity. So tomorrow's activity is broken up into 2 separate days. Let me just get out of here and just go back to the classroom because I don't want to take up more of your time. And I got to find my classroom because I think it's hidden behind. There it is. I'm actually in it. All right. So you are here for today. So I kind of opened up the notes. I put them in regular PowerPoint. This is the actual activity. I just want to make sure that you can see the whole thing. There's that image. Yeah, that's all of it. And then what I would do is I would handwrite the answers. And then what would happen is you would end up with going to the Edulastic. This one's going to take me a little bit long to grade because they're open-ended questions. Again, don't be so overwhelmingly concerned with the grades. Really, all I'm doing is grading this stuff as either complete or incomplete, just so that you can keep in mind, there are 11 weeks. Each day is a piece of evidence. Each piece of evidence is like 13, 14 questions. It's 1 point per question. So you'll have somewhere up to 50 different assignments for the whole trimester. And those are just the evidence that you were actually participating. If you have questions on any of these, just feel free to reach out, send me an email, and we'll do the best that we can. But anyways, these are the questions. So if it were me, you can see from here that you want to have questions 1, 2, 3, 4, and 5 written out before you approach this. And then, oops, let me go back. Question number 6. It looks like, actually, I take that back. It looks like 1, 2, 3, 4, 5. Question number 7, which is number 6. I must have skipped one. Number 8, number 11, and then the extension questions. So the ones that it asks you to draw stuff, there's no way for you to enter that in Edulastic. So you don't have to worry about those. Oh, all right. So I think we covered everything. Let me see if I could stop sharing here. Okay. I'm just going to pause the